Welcome back students, and let's study touching circle theorem. Now the next topic what we are going to study is touching circles. Now what are touching circles? We have two circles which touch each other. Okay, now in this there will be two ways. One is the two circles are touching each other externally, means outside. Okay, and there will be two circles which are touching each other internally, that is one circle inside the other. Okay, now two circles which are touching externally, we can show the figure in this way. That is, there is one circle with center A, the other circle with center B. Okay, and both the circles touch each other at a point C. Okay, and this is line L which is tangent to circle with center A and tangent to circle with center B. That is, it is passing through the point C. Okay, and the other case is the circles touching internally. That is, you can see here a circle with center A is in the interior of the circle with center B, and these two circles are touching each other at a point C. Okay, and through this point C there is a line L which is a tangent. Okay, here you will see that point A, point B and point C, they are all in a straight line. Okay, even here when the circles touch each other externally, point A, point C and point B, they are all in a straight line. Okay, here if we have to write the betweenness, we can write the betweenness as A dash C dash B. Okay, if we consider the radius of the smaller circle as R1 and if we consider the radius of the bigger circle as R2. So distance AC is the radius of the smaller circle, let us consider R1, and distance BC is the radius of the bigger circle, let us consider R2. Okay, now if we have to find the distance between the centers of the circle. First, what is the distance between the centers of the circle? Center A and center B. So distance AB. And when they touch each other externally, we can see here that we can add the radius of both the circles. R1 plus R2 can give us the distance between the two centers. So here we can write the distance between the two centers. The distance between two centers when the circles touch each other externally can be given as R1 plus R2. Okay, we can add or we can take the sum of both the radius of both the circles. Okay, now when we go to the next, that is the circles touching internally. Okay, here you can see that the betweenness is B dash A dash C. Okay, so B dash A dash C. In this case, if we have to find the distance between the centers, now the center of this circle is A and the center of this bigger circle is B. So we have to find distance AB here. How we can find distance AB? The bigger radius minus smaller radius. First we will write here the smaller radius we had considered as R1. So this distance here is R1 and this is R2. Okay, so if we have to find AB, in the figure itself you can understand that distance AB will be R2 minus R1. Okay, so distance between two centers is equal to R2 minus R1. Okay, here R2 minus R1 can give you the distance between two centers, center A and center B, when the circles are touching internally. So, when the circles are touching externally, it is the sum of the radius R1 plus R2. R1 is the radius of smaller circle, R2 is the radius of the bigger circle. And when they touch internally, then it is R2 minus R1. R2 is the radius of the bigger circle and R1 same we have considered. R1 is the radius of the smaller circle. So R2 minus R1 when it is internally touching each other. Okay. Now we will study theorem of touching circles. Just before this I was teaching you all about circles touching externally and internally. Okay, and there I mentioned you all that the centers of both the circle and the point of contact, they are in a straight line, whether it is externally or internally also. In internally also, the centers of both the circle with the point of contact are in a straight line. Now in this theorem, we are going to prove that how these 3 points are in a straight line. So the theorem says, theorem of touching circles, if two circles touch each other, their point of contact lies on the line joining their centers. Now here they have shown both, that is the circles touching externally and circles touching internally. So in this particular theorem, we have to prove that these 3 points, that both the centers and this point of contact lies on a same line or lies on one line. That is, we have to show that they are collinear. Now, if we recall the tangent theorem, the tangent theorem says that the radius and the tangent are perpendicular. Okay, so in this case, AC is the radius, A is a center, C is a point on the circle. So AC is the radius and line L is a tangent, because line L is passing through this point C. Okay, now if AC according to tangent theorem will be perpendicular to line L. Same way even BC is perpendicular to line L. Okay, in this case also it will be the same thing, that is AC is the radius which is perpendicular to line L and BC is also the radius which is perpendicular to line L. Now if you observe that AC and BC are both perpendicular at the same point, that is point C. Okay, AC and BC are perpendicular on the same point, that is point C. And AC lies on the line L, whereas BC also lies on line L. Okay. So if AC and BC are perpendicular at the same point and AC and BC are perpendicular to the same line, okay, through this point C, there will be only one perpendicular which can be drawn. Okay, through C only one perpendicular can be drawn, and therefore we can prove that A, C and B lie on the same line and they are collinear. Okay, if we prove here, same applies to internally, touching internally also. Okay, and that is shown here, the theorem is written here, it is explained here. Clear? So you will go through the theorem, the statement, and after learning the 3 properties of touching circle, on page number 58 they have written all 3 together. Okay, so I will just read out. The point of contact of the touching circle lies on the line joining the center. Okay, so this is what we proved just now, that the point of contact and the centers of both the circle are in a straight line. If the circle touch externally, distance between their centers is equal to the sum of the radii. So we did R1 upon R2, same thing. Okay. And the distance between the centers of the circle touching internally is equal to the difference of their radii. And we solve their R2 minus R1, where R1 is a R1 is a radii of the smaller circle and R2 is a radii of the bigger circle we had taken. Okay, so remember these 3 points. Thank you.